So, good evening, everyone. I'm Prableen Kukreja, uh, PhD scholar at IIT Tirupati. So, we are going to start the Computer Network Week 8. So, let's start. I think last time we were doing sockets, and today we'll go through the socket programming. That is I think, as I asked you that whether we should do the programming or not, most of you were saying yes, we should cover the programming part. So that's why today we'll cover that programming part as well as we'll also start with the network layer. And in the network layer, I'll try to cover the classful and classless addressing at least, and I'll also go through the questions of that. This is uh, these are the things which we'll try to complete it today. I'll make sure that these things are completed because already we are lagging behind. So let's start. So anyone, can you tell me about what are sockets? Just in brief. Yes, come on.
Ma'am, sockets are the logical connection pipelines which help us to connect from the client to the server for data transmission.
Yes, absolutely correct. On point. That is a basically a logical pipe which is used for the communication part. Then we were going through each and all system calls which are used in the socket. We were doing so that we can it can help us in the programming part. So let's focus on the system call part very carefully. Listen it very carefully because when I'll do the programming, the same system calls, we'll discuss about that. So first of all, the first system call we discussed in the last lecture was the socket. Can someone tell me about this socket system call? At the server end, a socket system call is called. Can someone tell me about the socket system call with its three parameters? As we have already discussed.
Ma'am, the socket system call is used to initialize the socket transmission. And the first parameter domain is defining the protocol family like the IPv4, IP, the, the type of um, like the constant which we're using for the socket, like a socket stream for the TCP and socket diagram for UDP, and the protocol is the parameter which is normally set to 0.
Mhm. Absolutely correct. So basically, if I talk about the socket, if I talk about sockets basically they are the logical pipe coming to the system calls. This is the first system call which we are discussing. That is the socket system call. Whosoever has not attended the last lecture, it's totally fine. It's a new topic. The topic sockets basically in the transport layer, how there is a communication between the two ends with the help of the sockets. And then now we are discussing the system calls. So first system call is a socket, and it is basically called in the server end. And what does it mean? It means that this is an opening of a logical pipe. If I'm having the socket system call, which means okay, I want a logical pipe, I want a logical connection between two ends. So server basically initiate this socket call. Now usually when we initiate the system call as socket, we have three parameters: domain, type, and protocol. Domain is like what is the communication protocol family, which means I'll come to this IPv4 and IPv6 in the network layer. So basically which version of internet protocol you are using, or and this domain basically, if I have to write it, if I'm using IPv4, it is basically we have to write it as, symbolize it as AF inet. IPv6 AF inet 6. If I'm using local or inter-process communication, then it's like AF local or AF units, and if Bluetooth, AF Bluetooth. These are just the, I'll say, symbolization of these protocols. No need to remember, hardcore remember it. Just I'm telling you how we are like writing it in this socket. Now coming to this type. Type is basically we have learned about TCP and UDP in this transport layer, uh, TCP protocols. So what is the type of the protocol you are using? That is TCP or a UDP. If you are using TCP, then we are writing it as sock stream, and if we are using UDP, we are writing it as sock datagram basically. And protocol, again, that is TCP or UDP. If I'm writing any doubts? Okay. Please mute yourself if you are not having any doubt. If you have any question, please unmute yourself. Otherwise, please don't unmute yourself because there's a disturbance in the class. So, if I talk about the protocol is basically, if I'm writing it as 0, it means it is automatically selecting the default. Which means, like, if I'm writing 0 here, which means that it is automatically selecting default protocol. So suppose I was writing the type here S stream, so it will automatically select as TCP, which it will automatically know, okay, sock stream means TCP only. So that's why it has automatically selected this TCP here. Now coming to another system call, which is bind. Now, can someone tell me about the bind system call as well? I hope so. The socket system call is basically cleared. Is it clear? Because it's the main system call, a socket
Yes,
system call. What about others? Okay. I hope so. It's clear. Now, can someone tell me about the bind system call as well?
Ma'am, the bind system call assigns the port address to the socket with a port number and the IP address in which the client has to bind.
Absolutely correct. So basically, if I talk about the bind system call, in easy words, I can say that it associates the socket with specific IP and port number. So is it on the server side or it is on the client side?
Server side.
So basically, first I'm calling the socket system call to create a logical pipe, and then associating that socket with the IP address and the port number on the server side only, basically. Now coming to the parameters which are there in the bind system call.
Ma'am, the socket ID, the address
Yes.
port, and the size of that address.
Yes. So how come, what is the socket ID? Can you tell me?
Ma'am, the socket ID defines the socket descriptor of the client.
So basically, one more thing I want to tell you, when I'm calling this socket function here, the socket system call, I mean to say, it returns the socket ID to me. When I'm like this system call is called, this will return me a socket ID. That socket ID is used here with the bind thing. So it is basically returned by socket system call. Is it clear? So now address port. What is address port? Yes,
Ma'am, the IP address or the port number which is assigned to that particular, I mean, while creation of the socket.
Yes, absolutely correct. Now this is the IP address and the port number of the machine, and the size, I'll say that is the size of the socket address structure. I'll come to it in detail, and if you're not able to understand each and everything, it's fine, totally fine, because in programming also, I'll come to again to these functions as well. So whatsoever is not clear, we'll again go through that programming part, but I want it should be clear now only, so that in programming it will be easier for you. So coming to the bind part, socket part is over. We got to know, okay, the socket is like, I have created a logical pipe between them, a logical connection between them. Now in the bind part, I'm specifying the IP address and the port number. So there are three parameters here: the socket ID, this ID is basically returned by the socket system call only, which I have initiated, the server has initiated earlier. Now, the address port is basically, as one of you have told me, that is the socket, like address of the IP address and the port, or the port number of the machine. Basically, I'll come to this. And then that is the size is the size of the socket address structure. Now, coming to this address port, let us see. Basically, if I talk about this address port, we usually write here struct socket address in and then server address, which will contain here the SYN family. Basically, this struct socket address in, I'll come to this in programming as well. Don't worry about that. What is struct and what all these things basically mean. What are these? But in short, if I want to tell you, I'll again come to this. Don't worry. It will contain the SYN family. So if I'm writing here, can someone tell me what is this address? Okay, we have done socket. Now bind. Now in bind, we are telling about the address thing. Now in address thing, can you tell me about this address? Like how we are telling about the address thing? Can someone tell me what is the SYN family? What is the SYN address? What I have written? Yes, come on. I hope so. You have listened to the lecture as well.
And the SYN family defines the protocol family which will be used, like the AF-INET or AF-INET 6, whichever. And the SYN address defines the address which will be used, which is mostly assigned to IPv4 addressing. So it is, if I'm not wrong, so it is assigned to in ADDR any, and the port is um, changed with the hturns function, and then it is used.
I'll come to you. First part you said AF init. That is correct. As we have now only done, AF init is basically which protocol. That is like, suppose I have written AF init, which means IPv4 protocol, as you have told now only. SYN family, which means which protocol is used. So that is correct. Address, first of all, in address, I have to mention which protocol to be used. Then I have to mention like what is the address. Now this in address any, it doesn't mean that it's something related to IPv4. It means that, as you can like see here, any here in address any, and you can think that what does it mean? It means that you can listen to on all available network interfaces. Come to it, wait a second. Basically, I can listen to any address, whichever address, which if I'm writing a particular address, that is something different. If I'm writing in address any, which means that I can choose any of the address. I can listen to all the available interfaces. I'm fine with whichsoever client is sending me the data. I'm fine with that. I'm not mentioning only this client can send me the data. I'm saying that all the network interfaces can send me the data. I can listen to all. Is it clear?
Yes, ma'am.
Now coming to SYN port. SYN port means the port number here. Now, what is this H turns? I have written this H turns just to, can you tell me what is this H turns? You were trying to tell that something conversion. Can you tell me
Yes,
what?
ma'am. It converts the 16-bit host node to the 16-bit network byte through this function.
So basically, correct host byte order to network byte order. I'll come to it. So what is this host byte order and network byte order? Okay, I got, first of all, I'll come to that H turns. First of all, how the address is there. I hope so it's clear now. First of all, what protocol is there. Then which address I can listen to, as I have written in address any. So server can listen to any of the addresses. It can available to listen to all the available network interfaces. And then the port number is there. So it's simple, the protocol, the IP address and the port number. As we mentioned that this address will tell us these things only. So it's clear. Now coming to H turns, what is this function H turns used for? It is used for if I have a like conversion. Basically, I can also write here, rather than host byte order, little endian to big endian order.
Yes, ma'am.
And what is this? Can someone tell me little endian or host byte order or network byte? Like little endian is the same as host byte order, and network big endian is same as network byte order. No difference among them. So can you tell me? Can someone tell me what is this little endian and big endian? And I'm observing only one of you is answering. What? Where are others? Everyone is listening. It will benefit you all if you will be like interactive. Okay. So can someone of you can like tell me about what is little endian and big endian?
Ma'am, Little Indian means it will store the data in a least significant byte order, that is kind of like ascending order, and the big Indian means the most significant byte will be first and ending with the least significant byte. The
So
reverse of, yes, ma'am.
so can I say it's like just how to store the data in memory? That is the difference only.
Yes, ma'am.
Basically, what is little endian and big endian, or what is host order and byte order? How storing of data in memory is happening. As you said that either least significant or most significant, it is happening. And why we are converting? Can you tell me? Okay, you said me like uh, like suppose it was an example like 0A 0B 0C 0D, and it was stored like 0A 0B here, like in little endian first of all, and in big endian it was stored in the other way. Why we are converting it?
Ma'am, for security purposes.
Okay, can you think more? Someone else? Is it for security?
No, ma'am.
Then what others think about it? Yes, come on. Just a guess as well. I want that everyone should participate in the class. Yes, come on. Come on. Can I say that suppose the system is using little endian and this system is using big endian? So I have to basically convert it so that inconsistency shouldn't be there, to remove the inconsistency in the network. Can I say that?
Yes, ma'am. Ma'am, so basically conversion for Type compatibility.
Compatibility, absolutely correct. So basically for the compatibility, so that's why we are using this function. This function is basically hturns or hturn L also we can use. This function is basically converting the little endian to the big endian, basically for the compatibility. So if I'm sending from host to the network, and the network is basically using, rather than saying the system, the network is using the other big endian, and other host is also suppose using the little endian, then I'll convert it here, and then again I'll convert it back to the network, like to the host, basically the host order to the network order, and network order to the host order. If suppose medium is also not using the same compatibility, so that's why, like for the compatibility purpose, for the medium also, and for the systems also, if they are using little endian or big endian. So in other words, in short, as you have told it precisely, it's used for the compatibility. Now okay, we have done the two system calls, that is the bind as well as the socket. Now coming to the other system call, I think that is listen. If I'm listen. Can you tell me what is listen?
Ma'am, the listen uh, used to convert the unconnected socket into the passive socket.
Can you repeat? Active
And
okay, yes.
into the passive socket so that it will be active state whenever any client sends data for connection, and then
Mhm.
it will accept the data while listening to that particular request.
Mhm.
So it will come online.
Okay, so you have mentioned active. Okay, I'll come to that, active open and passive open also. Can I say in simple words rather than like using these terminologies? Can I say that server announce it, I'm running or I'm listening? I'm ready, basically, so that all clients can know, okay, the server is in active state in your like term. Is it correct?
Yes, ma'am.
So if I talk about listen also has, listen has basically two parameters. Can anyone tell me what are these parameters?
Ma'am, the socket ID is
Mm-hmm.
and the backlog is number of connections it can listen at a particular time. Maximum number.
Absolutely correct. So basically, this is the socket ID, or if I have written FD, the same thing, that is the socket file descriptor. I'm using it interchangeably. We can say it as socket ID as well, of socket file descriptor as well as, and backlog, as you said, the number of like connections it can, or I can say in other words, maximum number of queued connection before they are rejected. Basically, can you tell me what do you mean by maximum number of queued connection before they are rejected? Or if I'm writing here 5, what does 5 mean here?
Ma'am, that means five connection can be taken serially because they are in a queue, and
Yes,
rest will be rejected.
yes. Which means listen means I'm listening to 5 connections. I can accept only 5 connections. So if suppose I say if client connects while server is busy, can I say connection will be queued? Connection request is queued. In pending connection backlog. Tell you 1 minute. This backlog is, suppose I'm connecting, the client is basically connecting to a server, and now the server is busy somewhere. So now there'll be a queue in which the client will be waiting for it. And how many clients can wait for it? That is number of clients. Basically, suppose I have written 5. So client will basically be if the server is busy, client is basically queued in pending connection backlog. And suppose if queue is filled, and suppose new connection attempts, or I can say more than five connections are more than 5 devices are trying to connect, then what will happen? As I'm having the backlog number 5, now what will happen?
Ma'am, they will be rejected and not get an entry to the queue.
Yes, absolutely correct. That new connection request will be rejected. So this is basically listen system call. I've tried to explain in much detail that there is a socket FD and there is a backlog. And backlog also I tried to explain in detail that how many number of queued connections are there. And suppose if a client wants to connect to a server, then and if the server is busy, the client will wait in the queue. And if it is like suppose the backlog number is given, and if it's more than backlog number, then obviously it will be rejected because the server cannot hold more than these number of connections in the queue as well. Now there is an active open and passive open. Can you tell me about this? Can someone tell me about this? What is active open, passive open?
In the active open, the listen function is take act while the connections are being created, and in passive open, the socket is not accepted while the incoming connections are already in the backlog.
Basically, active open is like the client will open the connection only when there is a need of data transfer. Passive open is the server basically it will remain in the open state and it will wait for the incoming connection. It is announcing the address, it's in open state. Here it will only open when there is a need for the data transfer in active open. Is it clear to everyone?
Yes, ma'am.
Everyone is listening, first of all, or only Nilanjan is listening to me? Is it clear to everyone? Because now we are going to switch to, I hope so, many of the system calls we have discussed now, and many, okay, someone has written Dr. Savita, yes. What about others? Please give thumbs up if you have understood the socket concept. And if you have doubt, okay, please be interactive as well. Or if you want to write in the chat also, it's okay. But do answer the questions. Do try as well. It should, yes, yes. I got a relief by seeing that, okay, you guys are listening by giving thumbs up or by writing in the chat. It shouldn't be one way. It should be two way. You should also give the feedback so that I should understand, okay, I'll make more efforts if I'll think that, okay, you guys listen in the class. or you are also giving the input? So we have done these system calls. Now coming to the programming part, and now we'll try to understand it more clearly by the programming part. Wait a second. Now I'll disconnect from this.
Ma'am, I have one question.
Yes, yes, yes. Yes, Nilanjan. Am I audible?
Yes, ma'am. So in the number of data. Yes, ma'am.
Mm-hmm.
Yes, so suppose after X number of connections, the rest are rejected, and if suppose the X1 connection is getting rejected for certain number of attempts, and it will be flashed with some error message. So is there any attempt log, like after these many number of failed attempts, the data, I mean, you cannot attempt in the subsequent.
It depends on again, it depends on the application, how like you are designing it. If the application wants that, okay, after the certain number of attempts you can't, then it is basically application specific, how you basically wants to have that application. If after certain number of applications you don't want it, then obviously it will not have again, it cannot be connected. And if you want it, then it will be keep on trying. Like basically a threshold can be there or it cannot be there as well.
Okay, got it, ma'am.
Okay. Okay. Is my screen visible? So is it visible now? So this is the UDP server. Like basically I have written the code here of the UDP server and the UDP client, and then TCP and TCP client as well. And we'll try to understand it and run it. Basically I've already ran the code. Yes, visible. Okay. So we'll try to understand it. What are, I'll write the comments for each and everything so that it should be clear to you. So this is the code which is written in the C programming. First of all, these are only the headers. I'll not go through this. And this is argc and argv. First of all, coming to the main function, argc and argv. If I talk about argc, that is basically, which means argument count. What is argument? Anyone? I'm going through very basic part so that you should it should be understandable to you. Socket programming, we are like now doing it in practical. The parameters, like we have seen that, okay, the socket. Am I audible?
Yes, ma'am.
So arguments or parameters, we can say argument count, and this argv, which means how many I'll here write as well. I'll go through each and every line, don't worry. Which means how many number of arguments are passed by command line or terminal. I'll come to that, don't worry. If I talk about argv here, what is this argv? It is argument vector. An array of string passed. Now, what does this mean? If I'm coming to, I think this is UDP client one. This is UDP server one. Like how first I have compiled it, simply written GCC. This is how we compile this. The function, the name of the file, and then -o UDP server. Just compile it, and then I have called the UDP server, the name of the file, and the port number, basically the program name as well as the port number. So basically, I'm giving here the two arguments, which means argc is basically two. One is the program name, and the other is the port number. So argc here is 2, and argv here is the program name as well as the port number. Is it clear? Or I'll write this as well so that it should be clear. I'm explaining in much detail, so because of programming part. So here two arguments are passed. First one is UDP server, which is the program name, and the second one is the port number. As you can see here, I have written what I have written in terminal: UDP server, which is the program name, as well as the port number. Is it clear? Should I proceed? Very slowly I am going through.
Yes, ma'am.
So two parameters passed. So whereas if I say argv0 is this is the array argv. argv0 is basically UDP server, and argv1 basically is 9090, the port number. And it is, if I talk about the port number, it is passed as a string, the same as the program name. Now coming to this struct sock address in the server and the client address. We have already now only done that. What is this sock address in, where we studied that it's basically how we are writing the address. Basically, what is basically struct? Why we write struct in C? Can anyone tell me? What is struct?
Ma'am, it is a type of data structure used in. Yes, ma'am.
I can say a data type that groups multiple variable together. So if I want multiple variables like together, then I'm using this struct command. And here sock address in, that also we have saw now only that what is sock address in structure, which is storing network details like IP and port. I think we have seen in this. Is it clear? Till this part clear?
Yes, ma'am.
What about others? Nothing, just two arguments are passed, and then sock address. Now only we have done, it is used for storing the network detail addresses, basically IP address and port address. That is what is written here. Now, if I come to the sock FD and the server address, obviously, here it will store the server's IP and port, and client address, client IP and port. So, and struct is basically we are having multiple variables together. Now coming to sock FD, it's basically, what is socket FD? Anyone?
Socket file descriptor.
Yes, it's like an ID of the socket file descriptor. Port number stores the port number. Receive length stores the length of the received data. Should I write this also, or is it clear only the data, the variables which are used? Should I write in the file?
It's clear, ma'am.
Yeah, it's clear only. Buffer length, it stores the buffer size of the received message. Now coming to client length, basically it's basically this is the data type sock length T, and the client length basically it stores the Size of the client's address. Received buffer stores the received message, which can be maximum of 2048 bytes. Opt value, it will like store the socket option. I'll come to this. Opt value will come. We'll see that how, what is this?
Ma'am, this socklen underscore
Hmm.
data type is under the hash include ARPA/INET preprocessor.
Yes, 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 yes.
Okay, good.
Yes, basically these are used, these are basically included in these header files, as you are saying, ARPA, inet.h, these data types basically. So these are, if I talk about this, now it's clear. This is basically the server address and client address. These are ID, port number, receive length, client length, receive buffer, and opt value will come. Don't worry. This is just what I'm saying. These are just the variables which are going to be used, nothing else. Now coming to the main part. What does this mean? Can someone tell me what is this argc less than 2? Come on.
Hello.
Yes, yes, yes. Am I audible?
Yes, ma'am.
Can someone tell me what is this if condition?
Ma'am,
Yes.
it is less than 2, then only the print statement will be printed along with the first vector, I mean the first array element, and then it will be exited with a -1.
So what are they saying? What is argc?
And the argument command.
The argc means argument count.
Yes, ma'am.
So if argument count is less than 2, basically it will print what will it print?
Ma'am, it will print the first element of the array vector,
What is
argument
first
vector array.
element of array vector?
Yes, ma'am.
UDP server.
Yes, ma'am.
Use UDP server and the port. Basically they are saying that you should write both the elements, like the count shouldn't be less than 2. If it is less than 2, then the error will be there. This error will be there, the printed, and it will exit. Basically it will terminate the program with an error.
Okay.
Can I say? Is it clear?
Yes, ma'am.
So basically this exit -1 means that terminate the program with an error, and this means argc is less than 2, which means the count is not equal to 2, it is less than 2. So they are saying they'll print an error condition, error thing, and they'll basically terminate this. Now, till now, we have only initialized the variables. We have written that the arguments which I am passing here, these should be 2 in number, UDP server as well as 9090. These should be passed, the program name and the port number should be passed, and if it is not passed, the error will be there and the program will be terminated. Now, can you tell me what is this port number ATOI argv1? What does it mean? Any idea? What does this ATOI means? Can you just hold for a second? Like, I'll come in a minute. Please try to understand this program till that time. I'm just coming. Yes. Am I audible?
Yes, ma'am.
So can you tell me what does this ATOI means?
Ma'am, it converts a string value to an integer value.
So absolutely correct. Basically, it converts string to integer. So what we are doing here, what does argv1 means?
And the second element of that array
What is the second element of the array?
port number 9090.
So basically, we have written in the UDP server 9090 in our terminal, as you can see, and it was written in the string. Just I'm converting that port number to the integer. That ATOI function is basically helping me to do that. Is it clear? Just the
Yes, ma'am.
minimal things what I'm doing. Now, can some one of you read the second line and tell me what is happening?
Ma'am, it is we are storing the socket function return call using the protocol family and the type and also the parameter, storing it into the socket FD variable and checking if the socket FD variable is negative or not. If it is, then we are printing an error in opening socket and then exiting with +1.
So basically, we have done the presentation as well. Like this is a like creating a UDP socket.
Yes, ma'am.
This is a socket system call. We have already done in this socket our presentation. What is this socket? We have done that. Okay, it will contain 3 parameters. First one is that what will be the AFINET means IPv4 protocol. What will be the protocol? SOCDRAM means that okay, I'm using what would be the transport layer protocol, which means if SOC stream is there, then TCP. As we are now doing the UDP function, UDP program. So this basically SOC dgram, and 0, it is basically like 0, it will automatically take the default UDP protocol. Is it clear? I think we have done it. The socket, 3 parameters, the protocol, and the like IPv4, IPv6, or local or Bluetooth one. Then the transport layer protocol, and then what will be the again what will be the protocol here. And if we are taking 0, it will automatically take whatever we are taking from there. Like SOC dgram, if we are taking, then it will automatically take the UDP protocol. So here the server is creating up the socket, the first system call. And then if the socket basically fails, which means the socket ID is like negative, if this function fails, if the system call fails, it will print error in opening the socket, and it will exit the program. Clear till now?
Yes, ma'am.
What about others? Can you guys give thumbs up, or can you guys write in the chat? Okay. So hope so everyone is getting it. Now, can you tell me what is the other thing, what I have written next?
Ma'am, we are defining the scene family, scene address, and scene port for the server address
What
structure.
are these 3 lines? Can I say the addressing, configuring the server address?
Yes, ma'am.
So what does, now can you explain these 3 lines? Can one of you explain the 3 lines?
Ma'am, for the server lead type of the domain, and in the second line, we are defining the whichever active listening port is available for the server side, and third is the port number, which is converted using the hturns function.
Absolutely correct. So basically, first line, as we have done this, basically how to do the server addressing, the same thing we have done now only in the presentation also. So AFINET means IPv4 protocol. And in address any, now only we have done, it is bind to, like it can listen to all network interfaces. The server is saying it can be bind to all available network interfaces. And then this is the port number, and basically it is converted to network byte order. Now coming to this third, now this bind system call. Can you tell me about this? Yes.
Ma'am, it is checking if the bind is successful or not. If it is not, then it is printing this error message and exiting with the code 2.
First of all, can you tell me what is bind? Okay, that is fine. That okay, it is checking that bind is successful or not. Absolutely correct. Otherwise, it will say fail to bind, and it will exit and it will terminate. Absolutely correct. What is the bind? Again, we have done this bind. Like, what does this bind do? What are the parameters in the bind?
The bind start with the socket file descriptor.
Can
And
I say
then
the socket file descriptor I'm getting from here? I was telling you now that socket, when I'll have a system called socket, it will return me a socket file descriptor, which I'm using in the bind.
yes,
Is
ma'am.
it correct?
Yes, ma'am.
Then
And then it will use the socket address of the server using the struct function, and then it will
this is the
ask
size.
ask the size of that server address in the third argument.
So basically this socket server address, it is basically containing IP and the port number, the same thing which we have already mentioned, the server address. So basically it is binding the socket to IP and port address. These are the addresses, and this is the size of the addresses, and this is the socket FT which I am getting from the socket. So till now I have used these system calls as socket system call as well as bind system call. Bind is basically binding the socket to IP and port, and socket is basically initializing the socket in the server end. And these are the server addresses, which is basically like how to mention the server address, configure the server address. And again, if it is less than 0, which means if it fails, then we are basically returning it failed to bind and exiting it. Now this is the new a system call which we haven't done in a presentation, but I think it is explained in the lecture. Can someone tell me about the set socket opt? What is new in here? What is new here? Yes. Yes, come on.
I'm not sure with the SOL socket and SO reuse ADDR.
What about others? Yes. Come on.
Yes, ma'am. So I'm not getting.
Okay. So let's try to understand this set socket opt. Basically, if I'll write here only. Socket opt. This is the function which we are using to modify socket options at different levels. What I mean to say, whatever the socket options are already there, whatever the socket is already doing, our socket programming, we are trying to modify it. How we are modifying it? We are using reuse address. Can someone tell me what is the SO underscore reuse address? Any idea?
Ma'am, are we reusing the address of the socket?
Basically reusing the port of the socket,
Okay.
not the address. Basically, it allows the socket to reuse the port immediately. I'll write it. Just a minute.
Yes, ma'am.
Disturbance. So basically allows the socket to reuse the port immediately after it has been closed. I am whatever the port number is there. Again, I want to reuse the port number. Then I'm using this SO reuse address here, and this socket option. Basically, it is modifying whatever is already there. I can't reuse the ports, but I want to modify the socket option. So that's why I call this function set socket opt. Now, before telling about you reuse address, let's first try to understand set socket opt. What does it mean? Like, what does it do? Let's first try to understand this system call. First of all, I'll again come to that. What does it contain? First of all, it is containing the socket ID, the socket file descriptor, which I'm getting from the socket. Okay. Then the second thing is level. Like it is the sole socket, which means that the option, the level is socket level here. Obviously, we are using the socket here, so it's socket level here. Now, opt name, whatever you want to modify. What is the the option which you have to modify? Like I'm using here so our reuse address, which means I'm using the same address and port here. So basically, that is the opt name, the option to modify. And the next is opt value. I'm not writing here. This is basically, I'll say the pointer. I'll say here I'm using the pointer to the new value function, nothing else. And here the size of the opt value. The main part is here, this so reuse address. So if I have to modify already which the socket options, I'm using this set socket opt. Okay. Now the other thing is, this is only the syntax. Don't worry about this. Other thing is what I'm using. I want to reuse the port immediately. That is why I'm using this so reuse address. Why I'm using this so reuse address? Let us see. What do you think? Why to why I'm using this? Okay, I want to reuse the, I'll say, the port number. Why to reuse the port number? Can someone tell me? Can someone think about it? Yes. First of all, everyone is getting whatever I'm I think I'm being very slow. Already we are behind. Again, I'm being very slow so that it should be clear to you, because I think in lecture they were very fast. Is it clear now?
Yes, ma'am.
So can you tell me why we have to use this so reuse address? I'm going I'm trying to get to each and every point so that you guys should get it. I'll say simply, so basically like different processes on the same IP, they can have the same port number if I'm using so reuse address, basically because when I'm done with one connection, I can again go to the other. I can reuse the port number for the same process, basically. So different process for the same different processes, I can have the same port number. Or to make it quick, if I want to restart a server quickly, what I need that, okay, the same port number can be used. I shouldn't have initiate more port numbers. I can say to restart a server quickly, or allowing different processes so that they can have the same port number on different IPs. But on the other hand, if I'm using the so reuse address, there can be a issue as well. The issue can be there of security. Can someone tell me why security? Yes. Come on. Are you getting it? Is it clear? I'm
No,
asking. No. What about others? So basically, if I want to have the same port numbers for different programs, I am using the so reuse address. Or if I want to allow the socket to reuse the port immediately, I have closed the port. I want to start the server immediately. Then I can reuse the ports, basically. That's why we are saying reuse the ports here. Whenever I'm stopping it, I want to start the other part, I'll write here. What I'm trying to say is, so reuse address, it is like I want to reuse the port is used, the port number is used. Now again, I want to reuse that same port number. Once the server is closed, again it will have to initiate the port numbers and all. But if I can reuse the port number, I can do it quickly. So if I want to restart the server quickly, I can use the so reuse address so that the port numbers can be the same, and I can reuse it. So that's why I'm using this so reuse address. The other part is, if the other process can also be bind to the same port number, so the port numbers can be reused here. I'll not go to the issues and all. I'll not go to that depth. Just coming to this so reuse address. Simple. This is why I'm using the set socket opt. I want to modify the socket options which are already there, I want to modify that. And what I'm using here, I'm using the so reuse address, so that my port numbers which were used earlier, I can reuse it immediately rather than waiting for a long time. If I'm trying to reuse it immediately, which means I can different processes can be bind to the same port number, or I can say it can be restarted quickly rather than initiating another, giving the different port numbers to them. Now, is it clear? Again, you have an issue. I'll explain it in detail at the end of the lecture.
yes, ma'am, got it.
Got it. So this is nothing. Don't go in that depth. Just we have to understand about the sockets, the system calls here. It is a type of socket opt here, which is used here, like opt name. What is used here? That is the socket opt system call, which is used here. Now coming to
Ma'am,
this. Yes.
ma'am, so if we are using this reuse function, I mean this reuse argument to use the previous existing port number, then ma'am, any other website can intercept the previous port number and can get the data of that particular IP.
So that's why, if it can happen that, okay, the same port number can be used by the other, and that's why I was saying the security concerns here. Until the connection is not closed, another, the same port number can be used by the other process, and the security concerns can be there. I'll not go in that depth, otherwise you guys will get confused. Yes, sir, you are on the right track with the security concerns thing.
Got it, ma'am.
So now coming to this buffer length. So it's basically the size of, it sets the buffer size here. Now we are printing that UDP server listening on the port number this. You can see UDP server listening on port number 9090 whenever I am typing this UDP, the program name as well as the port number. This is being printed here. And while one, can you explain this part, anyone? We have now done, we have created a socket, we have bind the socket, we have modified the socket options as well. Now coming to this receive from. Can someone tell me? What is this receive from?
So ma'am, this thing is loading the size of the client and the client length variable, which is of socket length data type. And then the receive length variable, we are um, returning the value of the receive from function, which is taking the socket file descriptor and the receive buffer and the size of the receive buffer using the buffer length. And this zero parameter, don't know about it. And then it is using the pointer to the client address structure and also taking the reference of the client length variable.
Almost correct. So basically we are storing the client address size here, client length, that is there. Now it is basically receiving the message from the client. This function is used, receive from socket file descriptor, you know. What is this? Received buffer, storing the received message, whatever we message like we are getting. Buffer length, what is the maximum length? 0 here is basically flags and all. So no special flags are used. Like, okay, I'll not come to the flags and all. We'll come further, like priority or so, whether the priority should be given or not to any data or not. Okay, it's fine. Coming to this is basically storing the client address, whatever it is, and then storing the client address size. So this receive from is basically receiving the message from the client, telling how much should be the buffer length, how much should be storing the received message here in the received buffer, the address here, and the length of the address. And obviously, if this receive length is basically less than 0, or I can say there is an error, then the error message will be printed here. Now coming to this.
Ma'am, why we're using a reference pointer for the client address length, like
So basically,
and then client length? Yes, ma'am.
yes, you can complete.
Yes, ma'am. So we can simply use the client length variable other than using the ampersand symbol in front of it.
Okay, you're saying only in the variable. I can also write here. This is basically storing the client address size. If I have to they're, I think, pointing to that client address, client length. Okay.
Yes, ma'am, because there
Maybe
is no
huh.
pointer
Yes.
here. The reference is not needed.
Absolutely. I can use that as well. Okay, coming to that. I'm not going to the details of that ampersand or pointer,
Yes,
just
ma'am, yes, ma'am.
over. Yes. Okay, now coming to this, so that you can get the overall understanding. Yes. What is this NTO? And so basically here, what I'm doing is init NTO means here that it is converting the client's IP to the string here, whatever the client's IP was there. And then again, network byte order to the host byte order. Earlier, we were using HTONs, which were host byte to network byte. Again, we are reconverting it. And receive buffer, basically like storing the received message. So received from this and this. Basically, what is the I'm converting into the string from, that is why I'm this is a print statement only, that okay, I'm receiving from this IP, so that is why I'm converting back to string form. And then this is the port number, and then again I'm converting network byte to host byte so that it should be in a readable form. And then the receive buffer is the message which we are storing it. Is it correct? Only this is the print statement, reconverting back so that the print statement should look okay. And earlier we were using HTONs, now we are using NTOHS, network byte to host byte, so that left to right we can read it. This is client address, again converting. This is NTO, means IP to string. I'll write here. If I write about init NTOA, this is client IP. String I'm converting back. And if I talk about NTOHS, it is network byte order to host byte order. Host order. This print statement is there. Now the next is, what is this? I have received the message. Now I have to send it back to the client. This is send respond back to the client. Again, the socket FD received buffer. I'm sending the same message, that whatever I have received, receive length. This is the address of the client. And if it is less than 0, which means there is an error, then I'm printing the error message and terminating. And then closing it. Any doubts?
No, ma'am.
What about others? So again, I'll go through it in I'll get go over in the crisp form what we have done. So as we have done that, okay, there is a socket ID, there is a socket system call. So that is what, first of all, these are only the variables I have initiated. And if I'm starting a program and anything is missing here, the port number is missing here, then I'm printing the statement, okay, the port number is missing here, and I'm terminating it. Then as I have written the port number here, I should have converted into the integer form. That is what I'm doing it. Then we have done in the presentation as well that, okay, first of all, socket system call should be called. That is what it is called. And then we have done that, okay, it contains 3 parameters. Okay, that is what is the protocol and what is the transport layer protocol and all. Then the server address, this was IPv4. It can accept any network interfaces, and port number, which is converted from network byte order to the host byte order. Sockets is logical pipe is created, socket is created. Now I have to bind it to IP and port, given the address and all I have given it. And if it again fails, then the socket FD, I got it from the socket system call. It fails, then I'm printing it. Then I'm also using a system call, that is socket opt, which is whatever we are using the socket options, I'm changing them, I'm modifying them so that I can reuse the port number immediately. I can use here any other also. Then here I'm just writing UDP server listening to, just this is printing up whenever I'm calling this program. And then whatever the client is saying, I'm listening, receiving it. And the same thing, I'm responding back to the client here. That is what received hello. And if I say about the client, I'm entering the message here hello, and I'm receiving that. And then we can send the message also, the same message. Is it clear? Is this clear?
Yes, ma'am.
Please, can you give the thumbs up if everyone has like understood, or you can write in the chat. What about others? I hope so it's clear for everyone. Now coming to UDP client part. I don't think so it will take a lot of time, UDP client part. Now in UDP client again, like I'm defining the IP address of the server, meaning the client will send the message to the server like on the same machine only as I'm sending it here only. This is only the IP address. Now coming to these are again I'll say the variables socket address and socket address. This is the same. It will store the server's IP and port, the server address, the IP address and port. It will store. It's basically socket file descriptor. This is buffer is basically used to send and receive the message, and it is used to store the server address. Now I have written the comments here. It creates a UDP socket, and if it fails, then like an error is there, configuring out the server address, then sending the message. I think wait a second. Okay, I'm missing something. This PTON, can someone tell me what is this? Here. Yes.
Not sure, ma'am.
Okay, so basically this PTON means that again it's like I'm writing the server address here, whatever like server IP here. So basically it is converting this string to binary, and it is storing it in this server address.syn address. Basically converting this string to binary and converting and storing it in server address. A second. Now this print enter the message. When I'm running this client side, I'm just running this UDP client, whatever my program name is, that is UDP client here. So I'm running this UDP client as like this. Here the message is printed, enter the message. fgets is like a scanf. You know about scanf? Yes, anyone?
Yes, ma'am.
Like if we have to write an input, that's basically scanf. So here it's like scanf only, I can say. So but it includes spaces as well, I'll say. And so here I'm writing buffer, size of buffer, and stdin. Can you tell me about this? Can someone of you tell me about this? Yes. So whatever buffer means whatever message I have to send here, what is the size of that message?
Yes, ma'am.
And then I'm sending the same thing. Then I'm sending the socket descriptor, the buffer, then the string length, basically the size of that, then the flag thing, no special flags are there, and these are basically the addresses of them wherever I have
Ma'am,
to send. Yes.
ma'am, are we taking any input from the user? Like stdin is mentioned in the third argument.
Yes. That is what I'm taking the user input. Like here I am writing enter message, so here I'm writing hello here.
Okay.
So that's why if I see here in the server side, received from hello, you can see here.
Yes, ma'am.
So here I'm writing hello, and here you can see that it's received there. So that's why stdin, which means what input you are taking. Received, like then I'm sending the, and then I'm receiving it, receiving here. Why here is null? Okay, here I'm writing the server address. Why here it's null? Basically, client does not care about the sender's address, so we are using this null. If I can write this also as a sender address, where from it is like it should come from there. But here we are not getting concerned about the server address. Rest all is same here. So I'm writing here null. So what is the server response? That is here what we have written. I'll again go through it, don't worry. So if I go through the UDP server thing, it was, I think UDP server I have explained in much detail. The client thing I just skipped it off because it was almost the same. Like here I have done what we have done, created up the socket, then the binding thing, then some optional thing, and then we have received the message and sending back the response, like a message here. The same thing, creating up the socket, then what is the configuring the server address, then I'm sending up the message, and then whatever the response what I have received here. I'm writing here null because I'm least concerned about from where it is coming. So that's why I wrote here null. Is it clear? Do you want me to share these files with you?
Yes, ma'am.
Okay, someone has written here. Will you please share the program? Okay, I'll put this program in the drive file only. I think you are having the link, or should I share it again?
Ma'am, you can reshare it.
Okay, I'll reshare it after the end of the lecture. And after that, I'll again put these, after the lecture only, I think I haven't put the notes as well of the last 1 or 2 lectures. I'll put them also, and these files also. Now coming to TCP server. So what do you think? What will be the difference? Okay, this UDP server, I ran it. I'll show you. I have written like UDP server. I ran it with the port number, 2 arguments, as you have seen, the program name as well as the port number, and this was printed. And then in the UDP client, when I ran it, there was, as we have done the this was the print command, and there was an input. I wrote here hello, and here we have received the hello here on the server. So this UDP part is clear to you all? Should I proceed with the TCP part? Yes, come on. Come on.
Yes,
What
ma'am.
about others? What do you think? What will be the difference between these UDP and you have? I think so. You got the somewhat you got about the UDP. I think so. You got about something you got from this UDP server and UDP client. Now, what do you think? What will be the difference between TCP and UDP? Was it clear before only in the class, or you have got some clarity? Like, have I shared more inputs about the program?
Yes, ma'am.
What about others? What others think about that? Yes. I hope so. I have shared something extra than class in more depth and detail so that you can get the idea behind it very clearly. Okay. Now, can you tell me what do you think? What will be the difference between the UDP programs as well as the TCP programs? Yes.
Ma'am, will there be any reliability check or ordering over here when we receive the
Not
packet?
exactly. Can I say connection establishment?
Yes, ma'am. Yes, ma'am.
So basically, in the socket part, I'll share we'll have I'll say the connection establishment part, as you'll see here. So these are the header files. Okay, I'll explain these as well because maybe these are new to you. I'll say, if I talk about ARPA INET, these are providing me the functions which are like used for converting the IP addresses. If I say about these are, though I think no need, just for the information. These are containing the structures for internet domain addresses. These are stdio. I think you know that these are standard input output functions like printf, fprintf, and all. If I talk about sys types, these are type definitions in system call. And these are, as the name suggests, is socket. These are socket functions. Like socket system calls like socket, bind, accept, and all. UniSTD, like if I have to, like I have used earlier also, closing the functions, the closing of the sockets. So that close functions and all these are provided by UniSTD. C-type, I think C-type. What about that? I'll check the C-type. And this STD library and all, like we have used that ATOI function. Like for converting strings to integers and all, and string.h, I think you know that string copy and all strings functions. C-type, I'll check. I forgot
Ma'am,
about.
the C type is for character handling.
Okay. Yes, you're correct. So these are the header files, though we shouldn't go into that detail, just for the information. So these are the header files which we are using here. Now the main function. Can you tell me about this? I think so. Now, can someone explain me about these in detail? What is argc, argb, and all? Yes, come on. I was thinking that we'll do classful and classless addressing as well, but I don't think so, because the socket programming itself took a lot of time. Yes, come on.
Ma'am, the argc defines the argument counter, that is number of arguments, and argv is a vector array for number of for the contents of the arguments.
Absolutely correct. That is the count, and that is the array basically, which is stored in
Character
the.
array.
Absolutely correct. And if I say about TCP, let's see. This is the TCP server. Again, the same way. I've called to the program name as well as the port number. So again, it is containing two things: the port the port number as well as the program name. Then I'm checking if the port number is provided. If it's not provided, then I'm terminating the program. And these socket FD, these are here I'm declaring the variables. Again, I'll go fast because I think so last program also I haven't explained you about this. This is the structure. I'll say I'm not writing the comments again because in UDP server.c these comments are already written. For these are basically, it is for storing address information, and it stores the server address, IP address and port number, client address basically, It will store the client information once when the connection is established here. Because here we'll do the connection establishment as well. Again, socket FD, that is the file descriptor. The child FD, basically file descriptor for the accepted client connection. Here I'll write because there I was not doing any connection establishment. Here, first of all, connection is established between server and client. So this is the ID for the client, which is connected, I'll say. Then the port number, it stores the port number. And then the again, the same thing, client length and all, the client address structure. Then buffer, it stores the buffer to store the received data, and receive length basically stores the length of the received data. And this is like I have already explained. Again, ATOI port number, if I'm writing here 8080, then I have to convert this port number basically from string to integer. That is basically ATOI, and this std library is having that function, so that's why I'm directly calling it. Then the first step is create socket, which we have already done. What is create socket? arg1 v1 means that the port number was there in the first argument, whereas the 0th one was the program name, so that is being converted. Can someone explain me in very quickly the socket system call here, like till this point? Socket, configure server address, bind. Yes, come on. Yes, come on.
Ma'am, it is same again, like we are defining the socket function with the domain and then the type and protocol, and passing it to the socket FD variable and checking if it is negative or not, and then passing the error message and exiting the condition. And then we are configuring the server address with the IPv4 addressing protocol in the family, and providing the IP address using the htone long function, any of the address with network which is available. And then we are using the port which through the htones short function, and assign it to the scene port variable. And then we are binding the socket with the socket FD variable along with the server address and the size of the server address, and checking if it is uh, negative or not, and if it is, and printing out the error message and exiting second time.
Very simple. Absolutely correct. First of all, we are creating the socket, domain name, protocol, and all this part is the same as we have done. And then again, the server address, and we are accepting any of them. That is why we are using here in address any. And then binding basically the server to specified IP and port number. And if binding is failed, then we are saying fail to bind. Now, listen command. Basically, we are listening for incoming connections. And we are, now can you see, was it before in UDP there? We have used this like listen in the UDP or not?
No, ma'am.
So that is why, because here we are doing the connection establishment.
Yes.
Can you tell me what is this 5 here?
And the backlog variable.
I think we have done this listen and accept, which will be used in TCP, not in UDP. We have already done in the presentation that that maximum number of pending connections. These are basically 5, which are the number of backlogs. And the socket FD, that is the ID which I'm getting from the socket. So it is listening for all the incoming connections. This listen command. Now again, this can someone explain me about this?
Ma'am, it is again setting up the socket option using the socket
Hmm.
file descriptor,
Hmm.
the socket, and using any existing port number for a new
Hmm.
connection
Hmm.
with the option value.
Hmm. Absolutely correct. And then accept system call. The accept system call here, it is accepting an incoming connections and creating a new socket, that is child FD, which is here I have mentioned there. What is child FD? File descriptor for accepted client connection. So whatever we are accepting it, that we are receiving a file descriptor for that we are mentioning it as file child FD, and if there is an error, then it will print error in accept. And again we are printing it new connection from the address as well as the port number. Again, this NTO means again we are converting from host address to network address so that it should be readable. And again we are converting from integer to string for the port number as well. And now
Ma'am, I have one question I forgot to ask. Ma'am, we are using while loop with the condition of 1, which is always true. Ma'am, so will it turn into infinite loop if all the conditions are coming true all the time?
what others think why we are using while one? I also forget to tell you. Yes. What others think about while one? Come on. Okay, I'll come to that. Basically, I'll come to this is the iterative part. I'll come to the concurrent part. Then I'll tell you why we are using this while one.
Ma'am.
Someone want to answer it? What do you think? Why I'm saying that I'll come to it when I'll come to the concurrent part, parallel part, and I'm not going through it now. Any idea? Yes, I'm waiting.
No, ma'am.
What about others?
Is it for infinite loop?
What do you mean, like infinite loop? Like, okay, I'll come to it. Don't worry. Let's focus on this. I'll come to this while loop, then I'll come to the parallel thing. I'll explain this as well, why we were using this while one. Till then, you can think about it as well. Okay. Again, coming now, can you explain this? What is inside the loop? Yes.
Ma'am, it is receiving the data from the client and then checking if there is whether any data or not, and throwing the error message. And if the uh, data is equal to 0, that is no data has been passed, then the client will be disconnected because of no transmission. And then if it got some data, then it will simply terminate the string using the null character and then print whatever data it has received through that receive buffer variable.
Absolutely correct. So basically, we are receiving here the data. It reads the data from the client basically, and this is simple only. Whatever the child FD means, whichever what we have connected through, and what is the received data that we are saying. And this is basically we are as we know, we have done the connection by listening, accepting, and now this is a disconnect. Now we are basically closing it. It means that the client disconnected. Close the client. If the client disconnected, receive length is equal to 0, which means the client disconnected. Then we have to close the client socket and we have to exit the loop. And then we are printing the whatever the received data is there. That is what the whole program is there. Now, can you tell me what were the major difference between this TCP server as well as the client UDP server part? Any one of you?
Ma'am, the connection establishment and then
How
checking.
connection establishment? Like, what were the major functions which were not in the earlier part?
Ma'am, checking through the listen function.
Hmm.
It was not there in the UDP server.
Yes.
And checking the client connection through the child file
Hmm.
descriptor.
Yes, absolutely correct. Accept function was there. Yes. Can I say accept system call was also not there?
Yes, ma'am.
So basically this listen, accept, and basically this connection establishment, and then connection disconnection disconnect also, connection if I'm when I'm disconnecting
No
also.
three-way handshake was there, kind of.
Three-way handshake, very well said, that three-way handshake was not present there in easy words, I can say.
Yes, ma'am.
Now coming to TCP client, can you explain this? Can someone explain this whole program very quickly? At least
Ma'am,
try, as we have
here
already
also we are taking the argument through the argc and argv,
Hmm.
and then we are describing the structure, declaring it, the socket address, and then the uh, host server, and the host character host name, and all the variables like socket fd, port numbers, send buffer and receive length, all this. And then we are checking if the arguments are correct or not through the argument count, and printing an error message respectively.
1 minute. Here, let me open this. This is TCP. Here I'm writing TCP client localhost at as well as 8080. Basically the host name. Here I'm not. You can see that here I was giving the server IP. Here I'm not giving the server IP. That is why here I'm writing localhost basically, so that I'll basically convert this host name to IP address, this localhost to IP address, and then the port number. Do you got this point?
Yes, ma'am.
So basically here the server IP was statically given, here the server IP is not given. So that's why here I'm writing the host name. As we know that we can convert the host name to the IP address, that I'll do. And the same thing is the port number. So that's why I'm having the 3 arguments.
Okay, so ma'am, the host name and its conversion, and then the port number. Okay, got it.
So here I'm checking if the correct number of arguments is provided. Okay, done. And then host name is the RV1, and then the port number. I'm basically converting again from string to integer. That's also fine. And then create the socket. Is this fine? Should I proceed?
Yes, ma'am.
In multiple times. Now, can you explain this? Try to explain this. I have written the comment as well.
Now we're fetching the host name through this function into the server variable and checking whether it is correct or not.
So basically, somewhat partially correct you are. This you can see get host by name. This is basically this function, the header here. It provides the function. I'll say net db.h. This provides me this function. Copy paste. Now, any idea what I'm doing here?
Ma'am, it is doing that conversion part.
Yes. So basically host name I'm giving like localhost. So it's basically converting to IP address. That's what I need. There I was statically mentioning the IP address. Here I was not statically mentioning the IP address. I was mentioning the host name. So I used this function host by name, and it's basically converting my sending the parameter here host name. It is basically converting it to this IP address. So here, if the IP address is basically there is a null or it's not giving me, this is giving me an error. Now coming to this next line, any idea about this? This is like host name get host name, we have already done like in DNS also. If I'm writing google.com, you go everyone got this concept. Get host by name means like if you're typing in your browser google.com, and obviously it has to be converted to IP address. We have already done multiple times like what does it mean, like we can't remember all the IP addresses, whereas there should be a fixed IP addresses for the network. So that's why for the conversion of this host name to IP address, we are using this function here. I hope so. It's like you got this concept. Is it clear? Yes, class.
Yes, madam. Yes, madam.
Okay. Now coming to this. Any idea? So B0 here.
Ma'am, it is binary 0.
No.
Okay.
It's basically it is I'll not go in detail. Just zero, like as you can read here, zero out the server address structure. Basically, whatever earlier server address was given, it is clearing that server address so that to avoid the garbage value, it shouldn't take any value. It should be cleared off, and it should take the new values, whatever is given now. So that's why I've written zero out. Whatever earlier some garbage value, it shouldn't pick up. It is clearing this server address basically to avoid this garbage value. Now coming to this. Can someone explain me this part? I think first line is clear.
Yes, ma'am.
Yes, can you explain? Nothing. IPv4 we are using, that's what we are mentioning. Then what do we usually mention here? Let's see here. This was wait a second. This is the same as we were using in UDP. This was the IP address. Then we were doing, okay, let's come to this. This was the IP, this server address dot SYN address and all those IP and port number. But here I'm using this bcopy because I have already now resolved this host name to IP address. So I am basically copying the resolved IP address to this server address. Whatever the server whatever it was I got the IP address. I copied into the server address dot syn address dot synat. That's what I'm doing. And then again the port number, basically I'm converting the port number to network byte order. Cleared? Yes. Yes, class. Are you guys getting it? Yes, come on.
Ma'am, can you repeat the second line?
You got the IP address
Yes, ma'am.
from the host name. Just I'm copying it, whatever you got, whatever we are having, in this server variable, whatever we are getting, whatever we got the host name, we are basically whatever we got the IP address, we are copying it here. That is what we should It's here only, the server address.sin address. It will contain our IP address. It will contain our IP address. That is what we are copying it here. Is it clear? Don't go in that much detail. We should have this IP address here.
Yes, ma'am.
That is what we are copying it by taking it from here. Clear? Yes, come on.
Yes, ma'am.
And then we are converting again the port number thing. And now connect. Now can you tell what is the other thing? We are establishing a TCP connection here with the connect part. Again, the address is given, the size, the file descriptor, and if there is an error, we are printing an error here. And then we are printing connected to the server, host name and port number, as you can see. Connected to the server, the host name, local host, which was given on port number, whatever the port number is. Now sending the data to the server. Whenever I'm writing this, here you can see received hello there. Whenever I'm running my program name, the host name and the port number, automatically my server will have a receive here hello there. Like here I'm not having that input part. I'm just saying that automatically the server will receive the hello there. Is it clear?
Yes, ma'am.
So it stores the hello there basically. Hello there in the send buffer. I'll say string copy. Hello there is now in the string copy, and then this buffer length. This is the length of string length buffer. This is basically, it gets the length of the message. And if send socket fd, basically there is an error in sending, obviously the error in the sending message. This will send, basically it's send the message to the server, and if sending fails, then the error in sending, there will be the message here. Again, now the receiving thing, this will receive the message from the server, and if the data is received successfully, it will print it, otherwise that error in the received message. And then we'll close the connection. Clear? I hope so. I have made it clear, the overview, like maybe not try to like clear it to you in much detail. And I think it took 2 hours.
Yes, ma'am.
I was thinking that we'll do, I made the questions of classful and classless addressing as well. But this was also important.
Ma'am, can you explain the while part, like which we are talking
I'll
about?
come to it because I haven't explained the concurrent
Oh,
program. It's basically how many clients we are accepting.
got it.
I'll come to that while part again. In that, I'll not use that, or the change, there will be the change in the next class. Maybe I'll explain it.
Okay, ma'am.
Basically, it is related to like not the parallel execution. I'm only letting only one client here. Okay, I'll come to that part in the next class only. Don't worry. Is it clear? I think I may not able to do that concurrent part because it will take again a lot of time. Maybe we'll discuss in like the theory part of that, and you can try it by yourself. That parallel thing and all. I hope so. This UDP, TCP, I've explained in you in much detail. These are the iterative servers. When one client like is connected to the server, and they are not multiple clients are not trying to connect simultaneously. I'll come to that concurrent server as well, where I'll explain why this while part was used, and then how that concurrent servers are basically implemented. That I'll explain in very short, because I want that you should try it yourself. And if you'll not get that then at the last of, I'll say in the last of the sessions, in the last class or so, we can do that part. but I think already we are lagging behind, so it might not be possible for me to complete that concurrent programming as well, because programming, as you can see today, it took whole class for me. How was the class today?
It was good.
What about others? Yes. Thank you so much. I hope so. I have added a value to it. And more than lectures, I have tried to go in more depth of the programming part as well. Because I thought that, okay, it might be tough for you to understand this part. And as you guys also said me, I was thinking to skip that part, but you guys also said me, okay, let's go in depth for this programming. I'll also have this. Okay, one more thing. The drive link you wanted, no? Wait a second. Just a minute. Anyone has anyone is having the link of the drive, or can someone share in the chat box? Okay, I'll share it. I think 4 weeks are uploaded. I have to upload more. Is it opening? Can any one of you check? Tonight or max tomorrow morning?
Yes, ma'am.
Tonight or max tomorrow morning, I'll share the other notes as well as these 4 programs. Any feedback?
Classes were good and we're clearing the concepts.
Okay. Thank you. And tomorrow, in the next lecture, we'll try to complete this classful, classless addressing and this addressing part, as well as the routing part.
Yes, ma'am.
Thank you, class.
Thank you, ma'am.